Well, ahoy there, mateys, and Happy New Year. Welcome back. Yay, 2021 has finally started. Goodbye, 2020. All right, so we're going to move into Chapter 8, and it's going to start with a little understanding of three-dimensional shapes, what 3D means. So first of all, you're going to want some paper, pencil, notes. You're going to take some notes. All of 8.1 is pretty much notes. So if you don't take notes, that's not good. Take notes. All right, so first, explain what you think the difference is between a two-dimensional figure and a three-dimensional figure. Well, I'm just going to show you. So generally, if you're talking 2D or a two-dimensional figure, you're talking about like a piece of paper or a triangle or a rectangle or something that's just flat, 2D. Three-dimensional is like this box right here is three-dimensional. Anything that can contain space inside is three-dimensional. Maybe an almond roca tin, Mocha Roca, delicious, coffee flavored. So anything that can contain something inside is a three-dimensional object. So that's what we're going to focus on for Chapter 8 is three-dimensional objects. And now, this is where your notes are going to come in handy. These are words you're going to see a lot. Faces, edges, and vertices. The singular for vertices is a vertex. So write this stuff down. You're going to need to know it. So this shape right here, this is basically a trapezoidal prism. So prism is anything that stretches in like this right here. This is a prism. This Triscuit box, this is a prism. Anything that stretches up straight does not meet at a single point. So the faces are all of, we would call them sides if it were a two-dimensional shape. So like this front here of this Triscuit box is one of the faces. So this Triscuit box has 6 faces. It's got the front, the back, the left, the right, the top, and the bottom. Now edges are along the sides here. It's kind of where 2 faces meet. So like this has an edge right here, and it also has like 4 edges along the top here. So that's what edges are. And then vertices or a vertex, that's like a corner. So like this right here is a vertex. So the whole like 2D side is called a face. The line segments that are along the edges or are called edges. And then the vertices or a vertex is the corner. It's a point. So for that shape right there, this would have, as you can count on these green dots, there's 4 vertices on top and 4 vertices on the bottom. So there are 8 vertices. This has a small rectangle in the front, a big rectangle in the back, 2 rectangles on the sides, and then a trapezoid on top and a trapezoid on the bottom. So that would have 6 faces. And then for the edges, it would have these lines right here, the edges. So we got 1, 2, 3, 4 for this trapezoid, connected to this trapezoid, which has 4 more, by these 4 line segments. So we have 4 here, we got 4 here, and 4 down here, a total of 12 edges. Okay, so there we go. And 12 line segments, 8 points, and there we go. So 6 faces, 12 edges, 8 vertices. Okay, this video is going way too long. I'm going to speed it up. You can always pause it if you need. So for this one right here, how many faces are there in this triangular prism? Okay, how many edges are there in this triangular prism? And how many vertices are in this triangular prism? Okay, here are our answers. So the faces, again, are like the flat parts. So we got 5 faces. This rectangle, the bottom rectangle, and the 2 triangles on the ends. 9 edges, because we have 3 segments for this triangle, 3 more for this triangle, connected by these 3 segments right here, a total of 9 edges. And the vertexes are the corners, the points. So we got 1, 2, 3 in the back and 1, 2, 3 in the front. Okay. Example 2. Draw a rectangular prism. I'm going to show you one. Put this in your notes. So for a rectangular prism, this is the way I usually start it, is to draw a rectangle and an identical rectangle, and then you just connect them with lines that are parallel. There we go. Boom. That's how you draw a rectangular prism. It is called rectangular because the ends here, the edges on the ends, are rectangles. For a triangular prism, oh, well, there we go. Okay, for a triangular prism, this is one way to do it. I normally do a triangular prism the same as I do a rectangular prism. where I do two triangles. They're doing it with a base and a point. And then connecting it. Oh, I lied. That's for a pyramid, not a prism. Okay, for a prism, it goes straight. A pyramid meets at a point. So for a triangular pyramid, we draw a triangle, and then that's the base that meets at this singular point. So then you connect each of these vertices up to that one vertex at the top, and you end up with a triangular prism. Pyramid, I lied. Prisms go straight, pyramids meet at a point. Okay. Now, a hexagonal prism. What would the base of a hexagonal prism be? Yes, it would be a hexagon, a six-sided object. Also for your notes, if you don't remember, a pentagon is a five-sided object. So you'll see these terms used quite a bit. So hexagonal prism, does it have a picture for us? No, it doesn't. It's basically a hexagon and a second hexagon all connected with six edges to make a hexagonal prism. In a rectangular pyramid, you would draw a rectangle for the base and then a point at the top, because pyramids meet at a point. Okay, well, sorry I don't have pictures for you, but just ask me. Come during On Demand if you need, or just Google these terms. You can Google. It's very helpful. All right, so now here, what would the front of this here eraser look like? What about the side and the top? So part of your assignment will be spatial reasoning. You have to be able to picture these things in your head, and it sometimes helps to try to draw them on paper. So if I have this eraser, I'm picturing it in my head, the front of it is just a parallelogram. Okay, what would the top be? Yes, the top would be a rectangle. And then the sides here would also be rectangles. So the front, we have a parallelogram, top and the sides are rectangles. So you will have to be kind of breaking these three-dimensional shapes into two-dimensional shapes in your brain, and it helps to do it on paper. That makes it easier. So like for my almond roca can here, the top would be a circle. The bottom would be a circle. And then we're going to find out later, the side here is actually a rectangle. If I cut it and lay it flat, it would make a rectangle. So we'll be doing some of that in this chapter. So now here's some problems to do to help you get ready for the Big Ideas 8.1 assignment. So which of the following pictures is a square prism? Okay. Which of the following pictures is a pentagonal pyramid? And then for here, which of the following net patterns would be this particular, if I cut it and lay it flat, which of these would make this shape right here? And this is called a triangular prism. Ooh, there we go. Okay, there we go. Okay. And which of the following flat patterns would make this? This is called a square pyramid. Okay, I'm not sure what the pictures are going to be when they, oh, there we go. So that there is a square prism. It goes straight. Pyramids meet up at a point, and this pentagonal means it's a pentagon on the bottom, a five-sided object on the bottom. And then the flat patterns will look a little different than this, the nets, but I'll let you know when you answer them right on Edpuzzle. Okay, so there we go. That is everything you need to know for 8.1. Again, hopefully you took some notes and wrote these things down. Use Google if there's terms you're not familiar with and you did not take very good notes. And then come in during On Demand if you need some